Right, final question. You've done really well if you've got to this stage. Okay, so it takes 0.50 seconds for an apple to fall to the ground. The initial velocity of the apple is 0 meters per second. Acceleration due to gravity is 9.8 meters per second squared. Calculate the distance fallen by the apple. Use the physics equation sheet. So there are only two equations on the equation sheet with distance. Okay, so the first one, okay, is that one, but it's got speed and it's got time. Okay, yeah, we've got time, okay, there, and we've got the initial speed or velocity. We haven't got the final one, so that one's not really suitable. The only other one with distance in is this one, a few below it, a couple below it, which is that one, the one that we've practiced a lot in class. Final velocity squared minus initial velocity squared equals 2 times acceleration times distance. You've got your distance there, okay, so we're going to use that one. Okay, so we write C F I F A to help us. Now there's no converting at all. There's no prefix there, no prefix there, no prefix there. Okay, there's no kilograms, so, or grams or anything, so there's no converting. Now we use our v squared minus u squared equals 2 times a times s. Now we want to work out the s. Okay, but what we can do is make life so much easier for ourselves, okay, and realize that we can simplify this. So I'm going to put the numbers in and then we're going to simplify it. So we don't know what the final velocity is, but we know the initial velocity is 0. So v minus 0 squared equals 2 times the acceleration. Okay, so we do 2 lots of the acceleration. So 2 times 9.8. Okay, so you could go 2 times 9.8 times by s. Okay, now what we can do is simplify that. So we can do 2 times 9.8 on its own, leaving just s. So you can do 2 times 9.8 gives us 19.6 times by s, and then we know that the 0 squared we can just get rid of because it's 0 squared. So it's actually v squared equals 19.6 times s. Okay, so as a result, remember that is an s, it's not 5. Okay, all we need to know now is what the final velocity is. Okay, so we've got acceleration, we've got the initial velocity, and we've got time. So we're going to want an equation with acceleration in. Now we could use the force equals mass times acceleration, but we haven't got the force, and we don't need the mass. So that's one with acceleration we're never going to use. It'd be silly to use that one. Okay, so what we are going to use is that one. Acceleration equals change in velocity divided by time. Because we know, if we know the initial velocity and we know the change in velocity, we can work out what the final velocity is. Because we know if the initial velocity is 0 and it changes by 10, then our final velocity must be 10. So we're going to use that one. Acceleration is change in velocity divided by time. So C, we don't need to convert. F, I, F, A. Now we write the A equals velocity divided by time. Okay, we put the numbers in its place. So 9.8 equals v that we're trying to work out, or change in velocity, divided by time, which is 0.5. Okay, now we want to rearrange that. So I'm going to rearrange it over here. 9.8 equals v divided by 0.5. We want to times, we're divided by v, so we times by 0.5. Whatever we do to the left, we do to the right. So 9.8 times by 0.5. That cancels that. So that just gives us v. Okay, so we write v equals 9.8 times by 0.5. We do that on the calculator. 9.8 times 0.5 gives us 4.9. Okay, so the answer is 4.9 is the change in velocity. Okay, so we know that it starts at 0 and it changes by 4.9, so that means our change in velocity must be 4.9. So what we're going to do is put that into our equation. So 4.9 squared equals 19.6 times by s. Now we want to get s on its own, so we divide by 19.6 and we divide by 19.6 on this side. That cancels that. So what we end up with is 4.9 squared divided by 19.6, okay, equals our s. So let's put that into our calculator. Fraction button. 4.9 squared divided by 19.6, okay, and that gives us that number, which is 1.225. So our answer is 1.225. Okay, so 1.225 meters.